Hello everyone, in this video we're fixing an asynchronous message lifecycle issue inside a subscription billing engine on Develow.com. Currently, to keep our webhook endpoint fast, incoming billing events are enqueued to Amazon SQS and handled asynchronously by a background worker. While the on-queue side works perfectly, the processing worker has a critical bug. It receives and applies messages to the ledger, but never deletes them. SQS only hides a message for its visibility timeout, meaning every message eventually reappears in the queue to be processed over and over again, causing duplicate ledger balances. We are going to jump into the Develow IDE, use the built-in DVL AI chat to isolate our background worker pipeline, and implement a clean message deletion routine to complete the lifecycle. To resolve this ticket structurally, let's leverage our DVL AI chat to figure out where our background processing rules live and how the SQS interface is structured. Demonstrating a clear discovery process using target prompts is exactly what interviewers look for when testing your prompt engineering skills on Develow. First, we ask the AI, where are the background queue processing workers located and which file handles draining the subscription webhook events? Next, we map our worker dependencies by asking what methods are exposed on the SQS contract inside the drain loop for managing message visibility and removal. DVL points us to the SQS client, highlighting that while receive messages handles retrieval, we must invoke delete message using a specific receipt handle to acknowledge consumption. Finally, we set our guardrails by prompting, what do the tests look like in the graded suite? The AI confirms that the tests expect every in-queued event to be applied exactly once to the ledger, and that after a successful drain, the queue must be completely empty, meaning both available and in-flight message counts must drop to 0. Let's jump into the code. The architecture requirement here focuses on completing the message consumption lifecycle: receive, process, and delete. Right now, the background worker has a planted bug. Whenever a batch of messages is pulled, it loops through them, extracts the payment object, and updates the customer ledger balance. However, it immediately jumps to the next message without acknowledging the current one. Because Amazon SQS relies on an in-flight visibility timeout to protect against worker crashes, a message isn't actually gone just because a worker read it. Our goal is to implement an explicit delete strategy inside the worker logic. As the worker loops through the message batch, it applies the payment metrics to the target customer's account ledger. Immediately following a successful ledger state update, we must intercept the loop execution and fire off a delete message operation. By passing the unique message receipt handle back to SQS, we permanently drop the event from the pipeline, ensuring it can never be redelivered or double processed. Let's open API folder inside that app folder. Inside app folder, open worker.py to modify our execution loop. Locate the drain routine where messages are pulled and processed. We can see the old buggy code that updates the ledger and increments the processed counter, but leaves the message floating in a visible state. We need to add an explicit acknowledgement line right before the loop tracks the message as processed. We call the deletion method on our SQS instance by writing sqs.deleteMessage. We provide the queue parameter using QU and the receipt handle parameter using message in square brackets, receipt handle. Let's trace this execution pathway. For every message in the batch, the worker securely updates the ledger balance. Right after that transaction, it grabs the message's unique receipt handle and sends a deletion call back to SQS. This completely halts infinite reprocessing loops while ensuring that subsequent event batches process purely unique transactions without duplicating balances. With our message lifecycle rules saved, let's pull up the integrated terminal window right here in the Develow IDE to verify our solution. We execute the validation suite, PyTest, or our target test script. The test framework simulates an incoming stream of webhook items, executes our drain worker, and verifies that customer balances match the exact payment totals. Because our delete logic is executing properly, the queue counts drop completely to 0, returning a clean, passing test suite across the board. Completing the full transaction lifecycle when dealing with distributed message queues ensures your asynchronous data architectures remain accurate and resilient against duplicate processing bugs. By using the DVL AI chat to isolate our SQS contract requirements, we were able to quickly seal this revenue leaking pipeline. This ticket is now fully resolved. Bye for now and see you in the next code challenge.